Solve equations and inequalities with variables on both sides by reading and writing in algebraic notation.
Lovely. That's what we're doing today. So we've already practiced how to handle it when we've only got one variable on one side of the equation. In order to handle variables on both sides, these are the things that we're going to need for today. We need to be able to talk about terms. Remember, terms are variables by themselves, constants by themselves, or a variable with some sort of coefficient. So it's going to look like this 8n. We're going to need to be able to identify our like terms. Remember, like terms are either constants or things that have the same variable with the same power. And we're going to make heavy use of the distribution property. It's going to look like this, has parentheses, there's addition or subtraction inside the parentheses, and we're multiplying by some number outside. And we're going to give that number outside to each thing inside the parentheses by multiplying it to everything in the parentheses. All right? Mm-hmm. You also need to remember that when you're solving inequalities, multiplying or dividing by a negative will make the inequality sign flip. As in this example. Okay? Notice here that to go from the first line of this quick example to the second, we had to divide by a -2. We flipped the inequality. All right? All right. Let's look at what it's going to look like if you have a variable on both sides. All right? It's going to look something like this. You're going to see the same letter on either side of the equals or the inequality, whichever we're looking at. And at the end of the day, when you're solving, you can have the variables on the left or on the right. And no one cares which one you picked. I'm going to show you what it's going to look like either way. Okay, so let's look at what happens when we decide we want all the variables on the left side. I'm going to collect the variables to the left. So what I'm going to do is I need to remove this term from this side. This term is positive or negative?
Positive.
Positive. So to undo addition, I'm going to use negative a subtraction. So I'm going to subtract 3x from both sides. Notice how I'm lining up your like terms. Over here, I'm going to be left with 2x minus 8. There's my equal sign. The 3x's cancel. And on the right, I have a 12. Now this looks like every other equation we've dealt with so far this year. So I'm just going to fly through the next couple steps. We're going to add 8 to both sides. And then I'm going to divide both sides by 2. And when I divide both sides by 2, I end up with x equals 10. That's what our final solution is going to look like if we've chosen to put the variables on the left-hand side. Let's see what it looks like if I decide to put the variables on the right-hand side. Okay, so I'm going to zoom it out just a little bit. Here's my equation again, but this time I want the variables on the right. So I'm going to collect them all to that location, which means I need to remove the 5x on the left. What's the sign on the 5x? Positive. Plus. How do I undo plus?
Negative.
Negative minus. So minus 5x minus 5x.
Negative 2.
These cancel. Negative 8 equals negative 2x plus 12. And again, this now looks like every other equation we've handled so far this year. So I'm going to fly through the steps on solving this. I'm going to subtract 12 from both sides. And now I need to get the x by itself. There's multiplication between the negative 2 and the x, so I'm going to divide by negative 2.
Negative 10.
And when I'm done, I have 10 equals x. Notice the value for x is the same. Just the statement that we're making looks a little different. There's no difference between these two. X equals 10, 10 equals x, totally the same thing. All right? It's just a direction thing. Cool? Right.